to be doing something called linear inequalities. This is very similar to just graphing regular lines, so I think that you guys will find it pretty easy. The only real difference is the symbol that we use. So let's pick our highlighter. You want pink or aqua? I'll pick aqua. So here, if you're going to be using either a less than, a greater than, a less than or equal to, or a greater than or equal to sign instead of an equal sign. So the first part of the process is still the same. The boundary line is just the line that's formed by the linear equation. It divides the graph into two parts. The one part is going to have all your solutions, where all your solutions will be contained, and the other part will have everything that is not a solution, or every point that makes your inequality not true. So when you have the inequality symbols that are less than or equal to, or greater than or equal to, we're going to make our line a solid line. The reason we want to do that is because the line is going to be included in our solution. Any point that lies on the line will make the inequality true. When the symbol is less than or greater than, the points on the line are not included, so the line is going to be a dotted line. That just means that if you take a point and you plug it in that's on the line, it will not make the inequality statement true. Now, the other part that's different from just regular graphing a line, if the y is greater than or greater than or equal to the expression to the right, then you're going to shade above. So that just lets you know which part of the plane you shade. If y is less than, then you're going to shade below. When we do some practice with this, we'll discuss that a little bit more in detail. Now let's just try an example. So here we're going to try to graph this inequality. Y is less than or equal to 3x minus 1. So I think that you guys feel comfortable with graphing this line, y equals 3x minus 1. It's a very similar process. There's just two differences. So the beginning part is the same. We still look for the m and the b. The m is still a slope, the 3. The b is still -1, the y-intercept. So we start by doing the same process. We're going to start with -1 on the y-axis, and then use our slope pattern to get to the next point. So up 3 over 1, up 3 over 1, and so on. Now, here comes the part that's different. We have to make two decisions. One, should our line be solid or dotted? That's the first thing we have to think about. How you make that decision is what symbol we have here. So because it's a less than or equal to, we're going to make it a solid line. Remember on the previous slide that if I have either less than or equal to, or greater than or equal to, I'm going to make my line a solid line. So here, this is solid line. The next thing that I have to determine is whether I want to shade above or below the line. So if you look on the previous slide, it says that if y is greater than, we shade above. If y is less than, we shade below. So here, my y is less than. So that means I'm going to shade below the line. Okay, some kids have trouble determining whether this is above or this is below and so on. So here, how you make that decision is you just go anywhere on the line, and then if you go up, that's above. If you go down, that's below. So here, if this part is below the line, then that means I shade this whole area. So now my graph is finished. Here I'm also asked to find one point that is a solution to the inequality. So I can just pick any point that's in the shaded region. So let's say I pick the point, I don't know, 1, 2, 3, 4, 5, 3. So 5, 3 is a solution because it's in the shaded region. Now how to verify your answer to make sure that you didn't make a mistake is to go ahead and plug it back into the original inequality and see if it gives you something that's true. So here, I'm going to take my y value and plug it in for y and see if it works. Y is less than or equal to 3 times x. My x value is 5 minus 1. So here I get that 3 is less than or equal to 14, which is true. So it looks like I at least shaded the right part of the graph. Now let's try another example that's on the boundary line. So that means you're picking a point that's on your line. So here I have a point that's on my line. That point value is 1, 2. Now let's see what happens when I plug it in. If I plug it into the equation, I get 2 is less than or equal to 3 times 1 minus 1. So I get 2 is less than or equal to 2. At first, I think that some students may think that that's not true, but because of this or equal to part of it, it is true. 2 is less than or equal to 2. That's why I made my line solid, to denote that I wanted to include all the points on the line. Now we're going to be talking about how to graph a system of inequalities. Everything that we've done so far this chapter has been something with equalities, where we learned how to graph it, solve by substitution or solve by elimination. So now when I'm trying to graph a system of inequalities, it's the same thing as before, except that now I'm graphing 2 inequalities instead of just 1. So the first step to do is solve each inequality for y. That just means get the y alone. That's what you normally do when you graph a line. Then the next one is to graph each line and then do the shading. And then the last step is to look where the 2 shadings from each line overlap, and you should just darken that area. So let's do an example. So in this example, we're lucky in the fact that the 2 inequalities are already solved for y. The y is already alone, so I can clearly see what my m and my b are. So here, my m for the first inequality is 5/3, and my b is 3. So now I go to 3 on my y-axis, and I put my point there. Then I just use the slope pattern to graph the next point, just like you normally do when you graph a line. So you go up 5 and over 3, and then down 5 and to the left 3. Down 5 and to the left 3 again. So now, before I make my line, I should decide, is this line going to be solid or dotted? So, based on what this inequality symbol looks like, it's just greater than, not greater than or equal to. So I'm going to make it a dotted line. Now, I just have to decide whether I want to shade above the line or below the line. Because its y is greater than, I have to shade above the line. So that's this part of it. Now let's try the other inequality. Same idea here. I'm still looking for my m and my b. So my m is 1/3, my b is -1. So I go to -1 on the y-axis, and then I go up 1, over 3, up 1, over 3, down 1 to the left 3, and so on. Now, you have to decide whether it's solid or dotted. So because it's less than or equal to, that or equal to makes the line a solid line. Now I have to decide whether I want to shade above or below. Because its y is less than or equal to, I shade below. Now, I know that when we were solving just regular systems of equations, we were always looking for the point of intersection. We're not just looking for one point of intersection here, we're looking for lots of points of intersection. So the answer is the whole region where the 2 shadings overlap, where the 2 of them intersect with each other. So that would be this area here, where both the green and the blue are shaded. So once you know what that region is, you should shade it darker than the rest of it to make it clear to me that you know the answer. Now, if you wanted to find an answer to this system of equations, you could plug a point in that was in this region. If you took that point and plugged it into both inequalities, it should come out true for both of them. So now let's just do one more example. So here we're trying to graph a system of inequalities that shade the solution set just like before. The reason that this one is different is that the y is not alone in each of these inequalities. So you have to do a little bit more work before you get started. Just like if this was an equation, instead of an inequality, you would still have to get the y alone first. So let's deal with this first inequality. The first thing that I would like to do is subtract 3x from both sides. Then I'm left with negative 2y is greater than negative 3x minus 4. Now to get the y alone, the next step is to divide both sides by negative 2. Maybe you remember this rule from Algebra 1, maybe you don't, but anytime you divide an inequality by a negative, divide or multiply, you have to switch the direction of the inequality. So what's greater than? Now it's going to become a less than. And then you just simplify the rest of this inequality to 3x over 2 plus 2. Negative divided by a negative is a positive. So my b is 2. My m is 3 over 2. So I go up 3 over 2, up 3 and over 2, and so on. Now that I have the boundary line graphed, I have to decide whether or not I should shade above or below. Now you have to look at this once the y is alone. You can't look at the original here. So now that the y is alone, y is less than. So I want to be shading below. And I guess I didn't make my boundary line. But before you do that, I guess you should decide whether your line is going to be solid or dotted. Because it's just less than, I'm going to have a dotted line. Now, let's try the second inequality. This one's a little bit easier because there's no coefficient of y. So all I have to do is subtract x from both sides, and I get that y is greater than negative x minus 3. So my m is negative 1, the number that's multiplied by the x, and my b is negative 3. So I go down to negative 3, and then I go down 1 to the right 1, down 1 to the right 1. Now I want to decide whether my line should be dotted or solid. Because its y is greater than and not greater than or equal to, it's going to be a dotted line. And I want to shade above because its y is greater than. The only thing that I have left to do is to darken the region where the two shaded areas intersect or where they overlap. That will be here. And that's it for today. Please don't forget to answer the questions. Thanks.